Hello, welcome back to Cinderella Math. Today we'll be learning how to solve quadratics, and particularly trinomials, so three pieces, using the magic X method. There are other ways to do that, so if you don't like this method, it just doesn't work for you, there are other ways. Search here on YouTube, you'll find a ton of other videos, but in my experience from teaching high school math, this is the easiest for me and typically for my students too. You can use a calculator if it's okay with your teacher. Feel free. And yeah, we'll go ahead and get started. The first half of the video, I'll be doing where the A value is just 1. And then toward the end, we'll do A values of not 1. All right, let's go ahead. So if you're looking for just factoring, I have another video on that. But today we'll be solving quadratics, in particularly trinomials, using the magic X. This is also sometimes called the AC method. Alrighty, so if you, real fast, if you would graph a quadratic, which has a standard form of ax squared plus bx plus c, if you just graph any quadratic, it is a parabola, right? If this a value is positive, it's an upward facing parabola like I have shown here. I call that a happy face. If the a value is negative, then it becomes a frowny face. That's if it's negative ax squared plus bx plus c. Okay? Three things can happen. When we're talking about solving these, we are finding solutions. And the solutions also have a couple synonyms here. The solutions are the x-intercepts. So if you are graphing these either by hand or with a graphing calculator, you're just going to click 1, 2, and you're going to jot down those x values. Those are your solutions. And they are also sometimes called zeros, because if you think about it, the whatever this is, it's over x up 0, right? So that's where the word zeros comes from. And then they're also called roots. Probably the name that's used the most is solution, so that's probably what I'll be saying the most, but those all mean the same things. In terms of solving quadratics, those are all interchangeable. Okay, so if you have a graph, if you're on Desmos, the graphing calculator, or you're graphing by hand, you are literally just looking for your x-intercepts. Okay? And again, we'll start where the a value is equal to 1. All right, so here's my first example. We have x squared plus 11x plus 10 equals 0. So if these don't equal 0, you'll manipulate it to get it equal 0. Probably in this video, I'll just have them all just straight up equal 0. But maybe I'll show one at the very end. If it's not equal to 0, you just move stuff over to get it equal to 0. Okay? All right, so let's factor. There's a 1 here. I would recommend putting in that invisible 1. Here's our A, here's our B, here's our C. Make your magic X. So if you're not familiar with this method, go on my channel on the Algebra 1 or Algebra 2 playlist and watch the factoring with magic X. Watch that first if you're not familiar. You're going to do A times C, so that's going to be 10, and the middle number is 11. So this is always AC, and this is B. So that's why this is sometimes called the AC method. I call it the magic X method, MA for magic, MA. We're looking for two numbers, that's going to go right here. Those are going to be our magic numbers that multiply to 10 but add to 11. So this part's optional here, but you're going to think of what multiplies to 10. So you don't have to write this down. If you're really good at times tables, you can probably do it in your head, or you can use a calculator. I like to write it down just to be thorough. What multiplies to 10? Well, 1 times 10 and 2 times 5. Out of those choices, which one's going to add to 11? That one. 1 plus 10 is 11. 1 times 10 is 10. So we make our factors. Sometimes I call these babies. See this x squared? 1 for me, 1 for you. And then your magic numbers were +1, +10. Those magic numbers can be switched, by the way. It doesn't matter. All right. Now, if this directions was just factor, you'd be done. But we are solving, so this still equals 0. Now think back to 3rd grade for a second. In 3rd grade, you learned that any number times 0 is 0. But also, 0 times any number is 0. Okay, so for this green sentence to be true, one of those is 0. We do not know which one, so we solve them both. You're going to set both of these factors, or babies, equal to 0. So do x plus 1 equals 0, subtract 1, x equals -1, and do x plus 10 equals 0, subtract 10, and x is -10. You can circle it like this, or especially for an upper level, maybe algebra 2 and higher, you probably want to do this. X equals squiggly bracket, the lower answer, comma, the upper answer. The squiggly bracket means that's the set of answers. Probably in Algebra 1, you can do this. If you're anything higher than Algebra 1, your teacher's probably going to want this. They're both right, just different notation. Those are your solutions, which again can also be called roots, zeros, and those are the x-intercepts. So if you actually have a graphing calculator, and you're welcome to do this, and you type this in, leave off the 0, just do that, you would see your quadratic having x-intercepts of -10 and -1. That is what we just found. The solutions, aka the x-intercepts. All right, let's do another. I'll do one more with that first number a being 1, because it is a little harder when a is not 1. Not by much, just a smidge. So here's example 2. I've got x squared minus 6x minus 40. And again, I would put in the 1. Always check for a GCF, by the way. This does not have one. Anytime you have a 1, you're not going to have a GCF. But check anyway. Just get in the habit of checking. All right, no GCF. We make our magic x. We do first times the last, which is -40. Middle number is -6. We're going to multiply here, add here. Again, you can do this next step in your head, on a calculator, or by hand. We're thinking of 40. I ignore the sign for a second. What multiplies to 40? 1 times 40, 2 times 20, 4 times 10, 5 times 8. Which one of those could give you a 6? 4 and 10. And we need it to be -6. So I need you to owe me 10, give me 4. Because then you would still owe me 6. So again, -10 plus 4, you'd owe me 6, but -10 times 4 is -40. Yay, those are our magic numbers. That takes practice. If you are new to this and you're like, wow, she just did that super fast. I know. It takes practice. You will get good at it, I promise. Okay, I've been doing this for 20 years. I haven't been a teacher for 20 years. I'm not quite that old, but I've been doing algebra for 20 years. All right, so give yourself grace. If you will get this fast, I promise. Okay, this is a super important skill in high school math. You will get there. Okay, make your babies. See this x squared? Split that in half. Put in your magic numbers, which was -10, +4. Oops, this equaled 0. I forgot to put that. This still equals 0. For something that's multiplied to equal 0, one of these has to be 0. We don't know which one. Solve them both. So x minus 10 set to 0. X plus 4 set to 0. Add 10. So x is 10 and x is -4. You could circle that. Just make sure you get them both. Or if you want to be fancy, x is the set, -4, comma 10. And we do put the set least to greatest. That's just proper notation. Let's make this a little harder. I'm going to do some where the A value, that first number, is not 1. Okay. Alrighty. Here's example 3. We have 2x squared plus 9x plus 20. So see, this A value is no longer that invisible 1. Okay, check for a GCF. 2 and 20, they're both even, so we could pull a 2, but nope, not going to work because we can't get it out of all of them. The 9 messes that up. So no GCF, but we check anyway. And now we'll go Magic X. And this is what I call cheat Magic X. Again, if you're unfamiliar with that, go on my Algebra 1 or Algebra 2 playlist and watch the factoring trinomial video, and you'll see what I mean there. You still do A times C, so that's 40. Middle number is 9. We need to multiply here, add here. Did I write this down right? Oops, I'm so sorry. Little typo here. That's a 10. Boop. That back number is supposed to be a 10. Still no GCF, but 2 times 10 would give us a top number over here of 20. My bad. We need to multiply to 20, add to 9. So thinking what could give us 20? Well, 1 times 20, 2 times 10, and 4 times 5. And that one will give us 9. So 4, 5. 4 plus 5 is 9. 4 times 5 is 20. We don't need any negatives. There's our magic. We build our factors. Oops, this still equals 0. My bad. See this x squared? 1 for me, 1 for you. And then these are our magics, 4 and 5, both positive. Now, this is a cheat because this first number was not a 1. So technically, when I did 2 times 10, once I fixed the problem, sorry about that, this is cheating. When it's anything other than a 1, again, watch my previous video if you want to see more of that in depth. So this multiply is cheating. So how do we uncheat? We divide, and you divide always this front number under your magic numbers. So we're going to divide 2 under both magic numbers. Now let's see if this simplifies. Well, 4 divided 2, this still equals 0, by the way. 4 divided 2 is 2. But 5 divided 2, I mean, it's 2.5, but no, let's just leave it. X plus, it does not simplify. Just leave it. Now, in my previous video, when we were factoring, and like the problem was just factor and then stop, I did teach that you take this denominator and you group it. You can do that if you want, but you do not need to group, okay? You can just leave the fraction because we're not putting this in final form as factors. We are solving. So I would recommend just leaving the fraction. You're kind of wasting a little time. If you swoop, you will still get it right. But you know, life's all about doing things efficiently, right? So you do not need to swoop. You can if you really want to, but you do not need to. Set both of these equal to 0. So x plus 2 equals 0, minus 2, and x is negative 2. X plus 5 halves equals 0, minus 5 halves, and x is negative 5 halves. Answers. Fancy, negative 5 halves, and negative 2 in the set notation. Either way is right. So yes, it is possible to get, quote, ugly answers on this, right? Fractions are our friends. Don't be scared. It's okay. And even if you do swoop it back, you'll still end up with the same answer. So again, that's fine if you want to. All right. Let me do one more. This will be a cheat as well. Trying to, there we go. All right, I think this is example 4. And my problem here is 6x squared plus 31x plus 5 is set to 0. So again, if it's not equal 0, you would just move things over to get it equal 0. But this one's good. Is there a GCF? 6, 31, 5. No, nothing comes out of those. I will do one more in a second with a GCF, or maybe one where you have to move over. I'll find one. All right, let's make our magic X. There's no GCF, so we just go right to the magic X. First times last, that would be 30. And the middle number is 31. Multiply here, add here. Okay, what gives us 30? Well, 1 times 30, 2 times 15, 3 times 10, 5 times 6. This one will add to 31. 1 plus 30 is 31. 1 times 30 is 30. No need for negatives. Yay. We make our two factors. See this x squared? 1 for you, 1 for me. Magic numbers, positive 1, positive 30, still equals 0, but oh, this is not a 1. This front number is a cheater. If you want to write that from the beginning, that might be a good idea, because that will remind you that we cheated, and we cheated by multiplying. So we're going to uncheat by dividing. And you divide that front number, that A value, under both magics. 1 divides 6. Ew, no, and that doesn't reduce either. Like if it was 2 divides 6, that would reduce, right? But it doesn't. Let's just leave it. You can swoop, but you do not need to when you're solving. How about 30 divides 6? Well, that's better. That's 5. So that's just x plus 5. This still equals 0, and now set both babies or factors equal to 0. So we have x plus 1/6 equals 0. I'm going to minus, and x is negative 6th, and x plus 5 equals 0. We're going to minus, and x is negative 5. Answer. X equals the set negative 5, negative 6th. And again, it's okay to get a fraction. That happens. It's fine. The downside to using a graphing calculator, if you were to like graph this, the negative 5 would be fine. Right here, this negative 6th on a graphing calculator, they're going to give you the decimal for that, and it's ugly. So this is still checkable on a graphing calculator. It's just not perfect. All right, let me find one with either a GCF or a where we need to move them. Give me 1 second. I can't make these up in my head because they may not factor right. All right, here. Okay, I found one. All right, so this is going to be an example of where it's not, oh, sorry, that's horrible, where it's not equal to 0. So here's example 5. I've got 3x squared minus 16x minus 7 equals 5. We cannot start until our quadratic equals 0. So we're going to need to minus 5 because now 5 minus 5 is 0. And that is a constant. So he doesn't have an x squared, he doesn't have an x. He's going to go right here on the other side. He's going to go with the other constant. So it's still going to be 3x squared, still going to be minus 16x, but negative 7 minus 5 is negative 12. Now this one, the black equation that I just put a star, that is where we're going to start the factoring. Check for a GCF. 3 and 12, yes, but the 16 messes it up, so no. So we'll just go to our magic X. 3 times negative 12, ooh, cheat. If that's not a 1, he's a cheat. So that's negative 36 and negative 16, okay? We want to multiply here, add here. What gives us 36? Ignore the negative for a second. Well, 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. Which combo would get us to 16? 2 and 18, right? And we need you to owe me owe me 16. So what if you owe me 18? Give me 2. Then you'd owe me, yeah, that'll work. So negative 18 plus 2, you'd still owe me 16. And negative 18 times 2 is negative 36. Yes. There's our magic. And again, yes, I did that fast. It's because I've been doing it literally for years, decades. You will get there. Okay. You don't have to do this off to the side. You can let your calculator help you. I like doing it off to the side, right? But if you're not so great at your times tables, this may not be the trick for you, but hopefully it'll help you learn your times tables if you're not great at them. It's a great skill. Okay. But you don't have to do that. Let your calculator help you, or some of you, if you're really good at your times tables, you can probably just get it in your head. Whatever method works for you, do it. All right, let's make our babies. See our x squared, cut in half, and our magic numbers was a minus 18 and a positive 2, but we cheated. Right here, this 3 is a cheat. When we multiply, that's cheating. It just is, okay? We're really not supposed to do that, but we have to get the magic x started. We uncheat by dividing 3. It's always that front number. 18 divided 3, that's just 6. Oh, this still equals 0. So this is going to be x minus 6, and 2 divided 3, nah, just leave it. X plus 2/3. And again, if we were factoring, we would swoop so that it's prettier, but we're not factoring, we're solving. So still equals 0. Set these both equal to 0. You would add 6, so this would be x equals 6. You would subtract 2/3, so that would be x equals negative 2/3. So final answer, I'm kind of running out of space. X equals negative 2/3 and 6. So we just had that one extra step where we had to move this beginning 5. We had to get it set to 0. Let me see if I can find one with a GCF though. Yeah, here, I found one with a GCF. This will be my last example. If you need more though, just please comment in the comments down below and I can make another video with more. This will be what, example 6? I have 7x squared minus 14x equals negative 7. So this is not set to 0. Let's add 7 because that would cancel and be 0. And then this would just come over here. It would not go with the x squared. It would not go with the x. It would just be hanging off, right? It's a constant. So our new problem is 7x squared minus 14x plus 7 equals 0. Now we start. So the jerk reaction is, oh, let's make that magic x. Yes, but no. Look very carefully at my orange equation. 7, 14, 7. Right here, we've got a GCF. All of those numbers are divisible by 7. So pull out that common factor of 7, divide it out. That would leave 1x squared. 14 divided 7 would be minus 2x. 7 divided 7 would be 1. There we go. Ignore that beginning 7 and do the magic x on the leftover quadratic. First times last, so that's 1. Middle number is negative 2. Multiply to 1, add to negative 2. What gives us 1? Well, that's just 1 times 1. But oh man, I need you to owe me 2. I think we'll have to make them both negative. Because if you do negative 1 plus negative 1, you owe me 1 plus you owe me 1, you owe me 2. But negative 1 times negative 1, negative times negative is positive. There's our magic. The 7 you drop down. So we have 7, and then our 2 babies, x for me, x for you. We did not cheat. This is a 1. So we do not have to worry about the cheating when it's a 1. Anything other than a 1, yes. And our magic numbers were minus 1, and this still all equals 0. Okay, so we technically have 3 factors for this. I'm going to have to erase here just for room. We have 3 factors. We have 7, x minus 1, and another x minus 1, and it still equals 0. You can leave it like this, or you can do 7x minus 1 twice. It doesn't matter, you do you. They're all going to get set to 0 either way. And that includes the 7. I know this seems weird, but this actually gets set to 0. But does 7 equal 0? No, that does not yield an answer. X minus 1 equals 0. This will yield an answer, and it's 1. And then you don't really need to do that one. It will be the same answer, and you do not need to repeat yourself. We just get one answer. This is x equals 1. So it's kind of weird to get just one answer, but it does happen. So usually you get two answers. This time we got one. And what that means, if you saw the graph of it, the quadratic, the parabola, would be touching just at one spot, kind of sitting right there at 1. So that's kind of a unique case, but it does happen from time to time. So that one was a good one. It was not equal 0, so we moved over. It had a GCF of 7, so we pulled that out. And then once we saw it was kind of a unique situation with just one answer. All right, I think I will wrap it up there. I hope this was helpful, and this is a great skill. So practice, practice. Just Google solving quadratics PDF. You'll come up with a bunch of practice. And if I can help you any farther, just let me know. Hope you're having a great day. Bye-bye.